Alrighty, so here we have a line, and we have point A. And then we have another point A, and then we have this smudge here that's not a point at all, it's just a smudge. The line is the perpendicular bisector of segment AB. But you say, where is AB? It's not there yet. We have to figure out where B is. Right? So there is some point B over here, so that the segment that goes from A to B is perpendicularly bisected by this line right here. Alright, so remember that the perpendicular bisector is perpendicular to the segment, and it cuts the segment in half. So there must be a point out here so that the segment AB will be perpendicular to this line, and B will be as far from the line as A is, because that's what it means to bisect, cut in half. It would be two equal-sized halves. So let's see, the slope of this line, I mean, we can get that pretty easily, is negative 2/3. And we can get that just by kind of looking at the line, but you could also get it from the equation. I would say 3y equals negative 2x plus 21. Now divide by 3, y equals negative 2/3 x plus 7. So the slope is 2/3 and the y-intercept is 7, which is, by the way, how we graphed it in the first place. So the slope of AB needs to be positive 3/2. All right. So if you look here, that means up 3, forward 2. Now for this first point, it just turns out that up 3, forward 2 takes us to the line. So up 3, forward 2 will take us straight to point B. Because we know that up 3, forward 2, if we did Pythagorean theorem, that would give us square root of 3, square root of 2, 9 and 4, square root of 13 from here to here. And then the same, up 3 over 2 is another square root of 13 out to B. So the distance from A to the line and the line to B are the same. So this is bisected. And it's perpendicular because the slope of this line is 3/2 and the slope of the original is negative 2/3. And they are negative reciprocals, like upside down negative versions of each other. Now the second point is a little trickier because if I go up 3 over 2, kind of carries me past the line over here. Here's another point. So if I were to kind of connect these, cool. Okay. All right. So that's this segment here, this line here is going to be perpendicular, true, but the problem is I don't know the distance from here up to here. All right, so what I have to do is figure out what that distance is so that I can sort of reflect this point A across on the other side to find point B. So what we're going to have to do is we're going to have to find out what's the equation of this line, and then we're going to have to use that equation to figure out where it intersects this line here, meaning this one. Once we find the point of intersection, well, then we'll be able to figure out where B is. So let's find that point of intersection first. The equation for this line, let's see, 1, 2, 3, 4 happens to be y equals 3/2 x plus 4. The y-intercept is 4, and we know earlier, because we made the line that way, it has a slope of 3/2. And so let's see. So we're going to take the x part of this equation, the 3/2 x plus 4, and make it equal to the x part of this equation down here, negative 2/3 x plus 7. So let's see, we will subtract 4 from each side, which leaves us with 3 over here. And then we'll subtract, or add 2/3 to each side, which is where, let's see here. Where did I put that? Yeah. I'm going to pause for a second. Oh, well, left that calculator at school, so we're going to have to do this by hand. Let's see. 3/2 is 9/6. Write this down. And 2/3 is 4/6. So all together, if I add them together, I have 13/6. And let's see, then we'll divide by 13/6 on both sides, which is the same as 3 times 6/13, and that makes it 18/13 for x. Let's see, 18/13 is a little bit over 1. Looks like our point of intersection is in fact a little bit over 1, so we're good there. Now we got to plug that back into one of the equations to find our y coordinate. So let's see, we'll do this one over here. Y equals 3/2 18/13 plus 4. So y is, see, 18 times 3 is 54 over 26 plus 4, 54 over 26. Let's see, that is 27/13. All right, 27/13 plus, let's see, 4 is 40/52/13. So y is 27 and 52 is 77/13. So 77/13 is, oh hey bud, hold on just a moment, okay? Let's see, 77/13 is, let's get regular calculator out here. Let's see, we have 77 divided by 13 is not quite 6. So let's take a look here. 1, 2, 3, 4, 5, 6. And it's just shy of 6. Here it almost looks like it's at the 6, but just shy of it. Okay, so this is the point. 18/13, comma, 77/13. Now I want to find where B is. So we know that the horizontal distance from 0, 4 to here will be equal to the horizontal distance from here to B. And the vertical distance from 0 to here will be the same as the vertical distance from here to B. So however far we go over and up to get here, we go over that much and up again to get to B. So let's see here. Well, see, it's 18/13. Our change in x is 18/13 minus 0. So that's our change in x. And our change in y is 77/13 minus 4. Oh, notice 77/13 take away 4 is 27/13. Did that one already. 27/13. So all we have to do is take these two values and add them. So the x coordinate for point B will be the 18/13 we have here, plus another 18/13, giving us 54. No, not 54. What am I talking about? 36/13. And our y coordinate for point B will be the 77/13 we have here, right, plus another 27/13 for a total of, see, 90, 104/13. let's get an idea of what those are. See, 36, so clear. 36 thirteenths is around 2.76, about 2 3/4. So 1, 2, looking at up here somewhere, and 104. 13 is 8 exactly. 1, 2, 3, 4, 5, 6, 7, 8. So it's right here. So point B is 36 thirteenths, comma 8. Oh, there we go. Okay. So overall, the procedure here was, well, we had the line. So we have point A here. I'm trying to find where point B is. I know that if I draw a line that's perpendicular to the original, that B will be on that line, and it will be as far away from the line as A is on this side. So I have the equation for the line, and then I set the two equations, put the two equations together to find their intersection point. Remember, to find their intersection point, you solve for x, and then plug that x in to one of the two equations to find a y. Therefore, we found our point of intersection, 18 thirteenths over 77 thirteenths, and 18 thirteenths and 77 thirteenths. Then we had to figure out, well, how far is it from here up to the line? And we could have done some like a distance formula calculation, but really we just need to know, well, what is the horizontal change from here over to this point, and then what's the vertical change from here over to this point, and take that horizontal and vertical change and add it again to these coordinates. Basically, we're saying, well, how far over and up, so we can go over that much and up that much again. And so we got those answers, and then we added them to the coordinates for that midpoint to find where B was. Flipped over on the other side. It turned out to be 36 thirteenths, comma, this nice easy 8. And a problem like that takes a while.